Okay, so let's start with the class, guys. I guess everyone is joining, right? Right? Yeah. Okay, guys. So yeah, so welcome to NEET World Institute and NEET World YouTube channel, and this is Vignesh, your physics lecturer, right? And today's topic is class 11th IPE, that is very short answer questions. The lesson which we are going to see in today's classes, system of particles and mechanical properties of fluids. Okay, let's go into the first question of today's class. So the first question is, it is necessary that mass should be present at the center of mass of any system. See, here is the thing, like people usually get confused, right? So when we talk about a regular object, like a circle or like a square, okay, like this kind of things, yes, obviously, like at the center is the center of mass. But when I talk about irregular mass, so suppose, let me consider at this point A and point B. Let me take point A is having more mass. For example, point A is having more mass at point A and point B having less mass compared to point A. Okay, compared to point A, point B having less mass, and compared to point B, point A is having more mass. So here the tricky point, like where the mass is more, there near to that a center of mass will be present. And when I talk about irregular object, yes, there is no center, that is not a center we consider as a center of mass. Okay, so simple answer is no. Okay, and for a uniform circular ring, the center of mass lies at the center of the ring where there is no mass. Got it? Got the point? What they are trying to tell? It is necessary that the mass should be present. See, this is center of mass, but everything is not constant. Like the mass is not exactly here, na? Like no need, like no mass is required, right? No. So this is the first question. When we talk about the second question, no, why should a helicopter necessarily have two propellers in the sense like two wings, na? So if there were only one propeller in a helicopter, then the helicopter would have to turn in the opposite direction to conserve angular momentum. Okay, so what they want to do, like would have to turn in opposite direction to conserve angular momentum. Hence, to avoid this, helicopter is provided with two propellers. So what is the main concept over here? Like the main concept is that is a conservation of angular momentum. Got it? Next question. We cannot open or close the door by applying force at the hinges. Okay, applying force at the hinges. Why? That is the question. Why? Okay, now if a force is applied to the hinges of the door, hinges like in the sense like the attached part, okay, hinges of the door, then the line of action, yes, I have told, no, then the line of action of the force passes through the point about which torque is to be calculated. Torque should be calculated. Okay, so in this case, no, torque will become 0, which means Rf sin theta is 0. Got it? So we cannot close or open the door by applying a force at the hinges, right? At the hinges. Okay, like simple thing. If you apply a force here, like this, the attached part. If I apply a force here and here, no, and in your homes or wherever you are going, no, like you will be seeing a door, right? No, so try to apply a force in this, like in this point near the attached part of the door, and try to apply the force in this point, both points. So apply equal force. Whatever force you are applying at this point and this point should be same, but which one is helping me to open fast? That's the point over here. Okay, that's the point over here. Okay, So this is about the first question, second question and third question of the system of particles. Okay, yeah, you can take a note of this and we can go for the next part of the question. Got it? Can we go for the next one? Okay. Yeah. The next fourth question and fifth question is visible in the board, right? Yes, fine. So let me take a pen first and we'll go for the questions. Okay. By spinning eggs on a tabletop, how will you distinguish a hard boiled egg from a raw boiled egg? So how can we distinguish, they're asking. See, when we talk about a boiled egg and a raw egg, no, like they're asking if I spin, how we can distinguish it's a oil, like it's a boiled or raw. Okay, I'm giving two eggs, like one is boiled and one is raw, and you are just spinning and you need to find which one is boiled and which one is raw. Like, okay, you should not break it. Okay, if you break it, obviously you can find it, right? That's not a thing. So boiled egg would spin for a longer time because it would act as a rigid body. Okay, why? Because like the particle has become closer, like it's tightly packed, one thing, right? Now it's tightly packed. When I talk about a raw egg, now it is a liquid part. No, it's a liquid part, so I cannot say it's a rigid body. But when I talk about a boiled egg, it's a like it's a solid part and it's fully packed, right? No, so would act as a rigid body. On other hand, a raw egg would stop spinning due to the loss of energy in overcoming viscous force. I told, like viscous force, where we are talking in fluids, right? So in fluids, we'll talk about the fluids chapter in next lesson. Okay, so also in case of the raw egg, the liquid matters would tend to move away from the rotational axis. See, yes, this is the egg, no, like I had please try to adjust the diagram. Okay, this is the egg, for example. When I rotate, this is the axis, let me take. So when I rotate, no, the liquid will come to this shell. Okay, the liquid will come to this shell. But when I talk about a raw, boiled, it's a raw. First one I have talked about a raw. Second one is a boiled one. Okay, when I talk about a boiled, everything is fixed. There is no place to move, right? No place to move. So whatever the particle is there, when I start rotating, it will be rotated to with respect to the fixed axis. Okay, so it tends to move away from the fixed rotational axis under the influence of centrifugal forces. Okay, this would increase the moment of inertia and consequently decrease the angular velocity. So when the moment of inertia increases, the angular velocity decreases. Got it? So this is the point, a simple point, like axis is there, liquid and the solid is there. Okay, like the fluid and solid is there. So when I talk about a fluid part, when I rotate it, it will go away from the axis. When I talk about a solid part, it doesn't. Okay, that's the concept over the fourth question. Next one is fifth question. Why are spokes are provided in bicycles? Like, yes, if you have seen these, like the wheels, no, like a scooter or any vehicle, two-wheelers or bicycles or anything, like why they have given these spikes like this? Anyone, like any point of time you would have noticed like why, like you would have think why they have given that one. Okay, why they have given that one? Yes, so this is done to increase the moment of inertia, right now. So like moment of inertia, like increase, yeah, even the mass is small, and this ensure uniform speed. The cycle runs smooth and steady. It's not only for the cycle, it's not only for the cycle, it's for the any vehicle, it's for any vehicles. Okay, so this is about the fourth question and the fifth question. So in this lesson we are going to concentrate on the more like theory parts. Okay, so try to understand the theory parts, the fourth question and fifth question. Okay, done. Can we go for the next one? Yeah. So two rigid bodies have same moment of inertia about their axis of symmetry. Of the two, which body would have greater kinetic energy? Okay, which body would have greater kinetic energy? So E is equal to L square by 2I. So what is I? It is moment of inertia. And what is L? It is angular momentum. Okay, angular momentum. So the body with a greater angular momentum will have the greater kinetic energy. So energy is directly proportional to the angular momentum. Okay, angular momentum. If angular momentum is I, then the kinetic energy is also I. Okay, the energy is also I. If moment of inertia is I, what about the energy? It will obviously decrease. Okay, so why it is, seventh question, why it is easier to balance a bicycle in a motion? So the rotating wheel of a bicycle obeys a law of conservation of angular momentum. Got it? Angular momentum. The direction of angular momentum is along the axis of the wheel. Okay, so when the rotation is taken place, no, like the axis, it's along the axis of the wheel. In the absence of an external torque, neither the magnitude nor the direction of angular momentum changes. Okay, what doesn't change? A magnitude or the direction of the angular momentum. Like if there is an external torque, then the magnitude and the direction will be changes. Otherwise it will be in the uniform. Okay, okay, so in bicycle balanced without getting tilted. Okay, got it. So the next chapter which we are going to see is mechanical properties of fluids. So I am going to take the two lessons today. Okay, why? Because like it's a small topics, right? We are discussing only very short answer questions here. Okay, so how many questions in the sense? 1 2 3 4 5 and 6 7 8 9 and 10 11 12 13. Yes, so only 13 questions is there. Simple 13 questions, we'll discuss it. Okay, so this is 13 and before one is, I guess it's 7. So total 20 questions only we are discussing today. We are not going to discuss more than the 20 questions. Okay, yes, next. So mechanical properties of fluids, this is the topic. So why liquid drops and bubbles are spherical? Why liquid drops in the sense like it's totally packed full of liquid, and what about the bubble? Like inside a space is there. Okay, inside air molecule, outside air molecule, this is a water molecule. Got it? This is the water molecule, right now. So due to the surface tension, raindrops and water bubbles are spherical in nature. Okay, surface tension, that's the main point. For a given volume, sphere has minimum surface area. So liquid drops attain spherical shape. So sphere has minimum surface area and it will attain a yes, it's a spherical shape. So next one, mention any two examples that obeys Bernoulli's theorem and justify them. So one is dynamic lift, which is in the airplane wings, And obviously you would have noticed this Magnus effect, like right now. So the people who would have who are now watching the football, no, like, yes, obviously that Roberto Carlos, yes, na, yes, that guy, like, he have opposed that, like, totally. He have overcome that physics point only. He have used this Magnus effect effectively, right? No, yes. So this is, if this is the goal post and the ball went in this manner, right? No, so it has taken the curved part due to the high pressure and the low pressure. Okay, yes. So without practice, no, nothing is coming. No, yes. So in physics also we should practice everything, then only it will come. Okay. So next one, when water flows through a pipe, which of the layer moves faster and slowest? Which of the layer in the sense, so suppose this is the pipe, okay, this is the pipe, and yeah, where is the pen? Yeah, I'll take the water. Okay, so water is going like this, no, water is going like this. So we'll be going in like n number of layers. Two of the layers will be attached with the surface. One is bottom surface and one is top surface. Now talk about the surfaces. So the middle center layer move faster. Why? Because is, so the middle layer, no, it doesn't have frictional, like more friction, because like top and bottom will be having the friction due to the pipe ends, like the side of the pipe. But when I come to the center part, obviously I will be like away from that. This side also I am away, this side also I am away. Okay, so obviously it will be going faster. And what about the slower? The outer layer, which is in the contact with the wall, yes, which is the contact with the wall, will have the slowest speed. Okay, that's the thing. That's the first, second question and third question gives. Got it? So if you have completed, we can go for the next question. Okay, done. Next questions. So what are the waterproofing agents and water wetting agents? What do they do? Okay, so little bit try to concentrate. So waterproofing and water wetting, two different things. So if a liquid doesn't wet the solid, then the angle of contact is greater than 90. Angle of contact is greater than 90. So the addition of waterproofing agent like waxy substance to the liquid increase the angle of contact. Waxy surface, okay, surface, I mean waxy substance. Okay, so water wetting agents. So water wetting agents are used in a detergent in order to clean the clothes. Okay, and the addition of detergent decreases the surface tension. Angle of contact is less than 90. Here angle of contact is more than 90. Okay, so what they do? So waterproofing agents reduces the wetting nature of a material, and water wetting agent decreases the surface of the liquid, and they by it spreads easily. So when I am using water wetting, like water wetting agent, it spread easily. Okay, so what is the principle behind the carburetor of an automobile? So when we talk about a carburetor, no, so carburetor of an automobile has a venturi channel through which an airflow will be larger speed. Okay, then the pressure is lowered at the narrow neck and petrol is sucked up in the chamber. Okay, so provides the correct mixture of air and the level of the necessary combustion. So it, like, carburetor is the part where the liquid part and the air, okay, the gas part will be used to mix. That's the point over here. Okay, so define average pressure, mention its unit and dimensional formula. It's a scalar or a vector quantity. That's the question. Okay, so what is the pressure? It's a force by area, like force per unit area we will talk right now. So unit Newton per meter square, otherwise we'll call it as Pascals. Okay, and this is SI unit. And what about the CGS? So sometimes they might ask the CGS unit in the EAP set examinations, right? So that is dyne per centimeter square. It's Newton per meter square. So Newton in terms of CGS it is dyne, and meter square in terms of it is centimeter square. Okay, yes. So dimensional formula is m L power minus 1 T power minus 2. Okay, so and this is a scalar quantity. Okay, it's a scalar quantity. So next question is define viscosity and what are its unit and dimensions. What are its units and dimensions? So it is a property of a fluid by virtue of its virtue of which one layer of a fluid opposes the relative motion of the other layer. So the thing is, when a liquid is there, some liquid is going in this right side and some other liquid is coming in the left side. Okay, so which opposes the relative layer. Okay, relative layer they are talking. Okay, and this is the force of opposition is known as viscous force. Okay, and unit is the coefficient of viscosity is Newton second per meter square, or it's a Pascal. Okay, done. So dimensional formula m L power minus 1 and T power minus 1. Got it. So what is the angle of contact? What is angle of contact? The angle made by the tangent drawn to the surface of a liquid at a point of contact of a liquid with the solid surface is known as the angle of contact, which like they used to measure that, right? Yes. So the angle made by the tangent drawn at the surface of a liquid at a point of contact of a liquid with the solid surface. Okay, so for pure water 0 degree, for pure mercury it is 140 degree. Okay, yeah, and then yeah, we'll go for the Magnus effect. So what is Magnus effect? Yes, listen carefully. We have talked about the Magnus effect in the previous case. What is the Bernoulli's application? One of the application is Magnus effect. So when a sphere or a cylinder moves in still air while spinning about an axis perpendicular to the direction of its motion, so its curved path is more curved than the when it moving without spinning. So this is called Magnus effect. Okay, like the simple thing is it will go in this manner. Right, let me take a pen. So yeah, in the curved path it will go, like it doesn't go in the straight path. So due to the low pressure and high pressure, it is going in this manner. Okay, so give the expression for excess pressure in a liquid drop. Okay, liquid drop in the sense only two surfaces there. Okay, two surface. So it is 2T by R. What about the bubble? It's 4T by, okay, 4T by R it will come. And T is the tension, surface tension, and R is the radius of the drop. And here if you see a soap bubble, soap bubble in the sense is a bubble which is having a like inside and outside. Okay, inside air is there, outside also air is there. So four surface, like 4T by R is the answer. Like surface tension is T, R is radius of the soap bubble. Okay, next one. So give expression for the excess pressure in air bubble inside the liquid. Okay, this question if you see, excess pressure of the soap bubble in air, that's it. And when we talk about this one inside a liquid, so 2T by R. Got it? So last question. So why are drops and bubbles are spherical? So the same question we have discussed, like similar type of question. For a given volume of sphere has a minimum surface area, because of the minimum surface area. Okay, because of the minimum surface area, it is, that is why it is in a spherical shape. Okay, so with this, so we have concluded the system of particles and mechanical properties of fluids. Very short answer questions. Okay, so we'll go with the next chapter in the upcoming classes. Okay, so thank you guys, we'll meet in the next class. Bye bye.